Good evening, and welcome to the second in a series of talks sponsored by the Society of Catholic Priests for Adorate 2023, a week of prayer, reflection, and worship during the Corpus Christi week. Tonight, we have the great pleasure of hosting a thought-provoking lecture and Q&A session with Professor Mark Harris from the University of Edinburgh. Professor Harris is a distinguished physicist and theologian whose work delves into the fascinating intersection between the natural sciences and religious beliefs. With his understanding of quantum mechanics, Professor Harris explores how this fundamental framework can inform and shape our theological understanding of the world. During tonight's talk, Professor Harris will shed light on the possible relationship between quantum mechanics and the Eucharist, that profound miracle where the Spirit universally and precisely transforms the elements into Christ's body and blood. Is it a category mistake to inquire about quantum divine action in this context? Or did Aquinas have it right with his Aristotelian understanding of transubstantiation? While Professor Harris has not promised to deliver any definitive answers to these questions, his talk aims to explore the Eucharistic mystery in contemporary scientific terms, inviting us to contemplate the interplay between faith and science. We are delighted to have Dr. Jamie Wright joining us as our responder for this talk. Dr. Wright holds a PhD in science and religion with a specific focus on the intersection of science, religion, and literature. With her diverse expertise, she will provide valuable insights and perspectives as she responds to Professor Harris's lecture and poses some questions for further exploration. We look forward to her valuable contributions to tonight's discussion. Without further ado, join me in warmly welcoming Professor Mark Harris to the virtual stage. We're honored to have him share his expertise and insights with us. Professor Harris, the floor is yours.
Thank you so much, Oliver, and thank you to everyone as well. On this lovely evening, you've opted to stay inside and watch me on a screen. So that requires a certain something. So thank you all. And I hope to make a certain amount of sense of this topic, although I have to admit that when we get towards the end, when I'll be talking about the title, I'm less certain about it. So I'd be very, very grateful to hear your views. Now, I'm going to share my screen so you can see some slides. Right, hopefully you can see all those. Please, someone shout at me if you can't see them. So just as a further word of introduction to me, in addition to what Oliver has just said, I used to be a member of SCP for some time, actually, when I was down in Oxford Diocese. But when I moved up to Edinburgh, I stopped being involved, not through any sort of conviction on my part or getting bored with SCP or anything like that at all. It's just simply lack of time when I moved into the academic field of science and religion. I think I'm still a Catholic priest at heart anyway. So Oliver suggested this title to me of Quantum Transubstantiation to explore the Eucharistic mystery of Christ's body and blood in terms of my research into quantum theology. Now, I hope that Oliver won't mind if I say that when he first suggested this to me, it struck me as a pretty outlandish suggestion. And I couldn't think of any other theologians who've ever done this before to talk about such a thing. But then the more I thought about it, the more I realized that if we are to take Christian convictions, like the doctrine of the incarnation, for instance, and the Holy Spirit's work in the world, if we take them seriously, then this isn't outlandish at all, but it's actually a potentially important area to explore, as I hope will become clear as we go along. And if you know, please shout out if I'm not being clear at all, or at least in the Q&A anyway. And like I said, I don't have clear ideas here about the Eucharist and quantum mechanics, but I will try to set out the main problems and the questions, and I would be very interested to hear your opinion. So here is my summary of what I'm going to say. I'm going to start off with this phrase that probably many of you have heard about: nobody understands quantum mechanics, before taking you straight into something called the measurement problem, which is at the heart of all what I want to say, really. And then I'll ask the question of what does it mean, before going into some of the main points of focus in quantum theology, and then ending up really in just the last 5 minutes or so in quantum transubstantiation. Now, before I get to the theology, I will need to spend some time talking about the science of quantum mechanics, which is outlandish in itself, actually. But I will try to keep things as simple as I can. But one point that often people coming from theology or the humanities don't necessarily appreciate about the way physicists use quantum mechanics. I mean, when I'm being a physicist, which I do a couple of weeks a year, not a great deal these days, I use the tools and the results of quantum mechanics every day. After several decades of working with it, it feels entirely intuitive and natural. But if you were to ask me, what does it mean? Well, I will quickly start to struggle, as you'll realize in this talk. And I'm entirely typical of physicists who use quantum mechanics. It provides a wonderful set of predictive tools, and it unites huge areas of science from physics and chemistry, material science, loads of different natural sciences. But nearly a century after the formation of quantum mechanics, we still don't know what it's telling us about the real world. So on the one hand, you will hear statements like this from the famous theoretical physicist Richard Feynman, who won the Nobel Prize for his work on quantum mechanics. He said that nobody understands quantum mechanics. If you'd think that anyone was going to understand it, it would be him. But on the other hand, you'll also hear physicists like me saying that quantum mechanics is the most successful framework in the whole of the sciences. So look at this famous example here. This is the anomalous magnetic moment of the electron. Now, you don't need to have a clue what any of this means, but I would like you to look at the numbers here, compare the experiment and the theory. And what you'll see is that the theory, which comes from quantum mechanics, agrees with the experiment to 11 decimal places. 11 decimal places. I mean, that is absolutely astonishing. There is nothing else in the whole of the natural sciences that can do that. And quantum mechanics has been tested countless times, and it's never been found to be wrong. So why don't we understand it? And why might theologians find all this very intriguing and very useful? Well, this is where we come to the measurement problem, or the infamous measurement problem, I should really say, because everyone always kind of quakes in their boots a little bit when it comes up. It is at the center of everything I want to say. And the easiest way into this is to explain the double slit experiment. And I'll show you some pictures of that in a moment. First to mention the guy who really kind of invented this area, Thomas Young, back in the early 1800s. He demonstrated to the Royal Society of London that light is made of waves using this experiment of the double slit. And this was very important at the time because everyone believed that light was made of particles, corpuscles, which was Newton's understanding. But no, Thomas Young demonstrated that light is made of waves. And that understanding that Thomas Young introduced then formed the whole of kind of classical physics, really, particularly Maxwell's theory of electromagnetism. You may have heard of that. One of the high points of classical physics, which allowed light to be explained in terms of what we now call electromagnetic radiation, which is enormously successful in classical physics. So let me show you what the double slit experiment looks like. If you look at the top diagram here, you'll see this is there's a set of light waves coming in from the left-hand side following the red arrow, and they impinge on a screen with two slits. And from each of the slits, the waves of light spread out in circles, and they interfere with each other so that the crests of the waves kind of add up, and then the troughs cancel out and so on, and you get this interference pattern on the detector screen with a series of bright and dark fringes. Okay, so what about if we do this with submicroscopic particles like electrons or atoms? Also, no, I should go in the in-between diagram. What happens if we do this with something like ball bearings, for instance? Well, we'd expect to see, and that's the middle diagram, we'd expect to see on the detector screen a whole series of impacts where the ball bearings have just passed straight through the slits and have impacted on the detector screen. So you see kind of two patches of impacts, if you like. Now, what happens if we do this with submicroscopic entities like electrons or atoms? Well, this is where you come to the bottom diagram. We see spots on the screen, which makes us think, well, they must be particles, these entities. But now we find that they're distributed in an interference pattern, like waves, which is rather strange. But we can do some experiments to try to probe things further. We can say, well, maybe this is a property of electrons or atoms, that they are particles which somehow interfere with each other when there's lots of them passing together through the slits. So let's send them through one at a time. And this is what we see here. These are photos that have been taken over time of electrons being passed through the two slits, one at a time. And you see that each electron makes a little flash on the screen, so it's clearly a particle. But as the pattern builds up, you see those light and dark fringes. It's almost as though the electrons are behaving both as particles and waves at the same time. Well, that's rather strange. And we've only sent each electron through once at a time. So does it split in half and go through both slits? Or does it become some kind of cloud that goes through the slits at the same time? Well, we can find out by refining the experiment further. And this is where it gets really strange. So I haven't shown this on my diagram, but if you put a detector after one of the slits to see which one of the slits your single electron goes through, sure enough, you find that 50% of the time, the detector registers that an electron's gone through it. And that implies that the rest of the 50%, the other 50% of the time, the electron went through the other slit. But what do we see on the screen now? Well, it's changed. What we find now is the middle pattern where, do you remember I told you about the ball bearings? You just see kind of two fringes, if you like. That's very strange. What we've done is we've managed to confirm that, sure enough, each electron does go through one slit or the other. They behave like good little particles. But where has the interference pattern gone? All we've done is watch the electrons, but we seem to have destroyed the interference. Well, it's almost as though our decision to see if the electron behaves like a particle has forced it to behave like a particle. Okay, there's one last thing we can do in this experiment. This has been done for real, so I'm just talking you through it. We can leave the detector in place, but we switch it off and hope the electrons don't know this, okay? And we find that the interference pattern returns. I mean, that's really strange. What's going on? Well, this is the heart of the measurement problem. The basic problem is that the electron doesn't seem to have an objective nature of its own that we can measure. Merely by trying to detect it or to determine if it's a particle or a wave, we force it to go one way or the other. We find that we are part of the measurement and we can't get out of that. So objective determinism, we might say, the objectivity of looking at an object, we are the subject looking at an object, it's been completely lost. Now, sometimes you'll hear this explained as wave-particle duality. This is the point that we need to understand quantum entities, electrons, atoms, molecules, subatomic particles, sometimes as waves, sometimes as particles, depending on the way we're observing them. Now, from the perspective of classical physics, so 19th century physics, that is a total paradox, because think about what a particle is. It's a tiny speck of stuff located in space. A wave is spread out in space. They are the complete opposite of each other. So how could one thing like an electron or an atom be both a particle and a wave at the same time? It makes no conceptual or classical, at any rate, sense at all. And even today, a century after these discoveries were first made in the early days of quantum mechanics, no one really understands what's going on here in any clear, intuitive way. Now, one of the big milestones back in the 1920s is what is called Heisenberg's uncertainty principle, and that's my only equation. The point here is that what Heisenberg discovered is that if you try and measure a basic property of a quantum entity like an electron, let's call it X, for instance, the position where it is, then it's related in a very peculiar way to another quantity called the momentum, the speed in other words. And what we find is that the more accurately we measure one, the less accurately we know the other. So if you want to know where the electron is, you won't be able to know what it's doing, and vice versa. And there is absolutely nothing we can do about this. Again, it's extremely unclassical and very unintuitive. No matter how much you try to improve your experiment, there are limitations to what we can know about the basic properties of these quantum entities. And this leads to what's often said to be the loss of determinism in physics. We simply can't determine what the physical world is doing in precise ways. So we have to resort instead to speaking about the quantum world in terms of probabilities and degrees of certainty, rather than of clear, precise, definite knowledge. Now, that has really important philosophical implications, because one of the most important beliefs in classical physics is that a complete knowledge of the properties of a thing would enable you to predict the future of that thing. But we can't do that anymore. So we might be able, for instance, to make really quite good predictions about some quantum phenomenon like radioactive decay, for instance, but actually those are statistical. There's a basic limit that we can't improve upon, even in principle. And what that means is that in physics terms, we can't predict the future. However good our science gets, the material world is indeterminate. And that means that we also can't make the usual assumption in classical physics that a cause always precedes an effect. So think about it. If nature is indeterminate at base level and doesn't have clear, predictable properties, then our assumption of a chain of causes and effects happening in the physical world just breaks down, at least at the quantum level. And that means that in the quantum world, strictly speaking, there's no cause nor effect. There are no events. There's no easy way of telling past from future or subject from object, which introduces massive philosophical questions about what on earth is actually going on. What does it really mean? So go back to the double slit experiment of the electron and the two slits. What exactly is the electron, remember? We changed it just by watching it. What is the electron when no one is watching? Is that even a meaningful question? Now, you'll realize that this is analogous to the famous problem of when a tree falls in the forest and there's no one there to hear it, does it make a sound? Exactly the same kind of question. And this leads to a debate between realism and anti-realism in quantum mechanics. Is there a reality out there, truly external to our minds, that's realism? Or is it the case that because we apprehend the external world through our minds, then the only reality that we can be sure of is mental? That's anti-realism. In other words, we construct reality merely by observing it, which is what we seem to be finding with quantum mechanics. So one of the basic issues or basic philosophical problems about quantum mechanics is that it raises this issue about, is there a real world out there, or are we making it up with our minds? Well, the famous or infamous Copenhagen interpretation takes a fairly anti-realist perspective on that. So the observer does play a part in constructing reality. Although most physicists who adhere to this kind of way of thinking, we do hope there's a real world out there, but we're aware of this anti-real problem. Well, in the early years of quantum mechanics, Einstein was very heavily involved in these debates. He was unusual then because he was a very staunch realist, and he tended to be debating these things with those of the Copenhagen school, who were the kind of strong anti-realists in comparison. And there was a famous debate about whether the moon exists when no one's looking at it. I mean, to Einstein, the answer was obvious. Of course the moon is there, even when I'm not looking at it. But to those in the Copenhagen school, they insisted that, well, we can't be sure of that. And the answer was that, however hard Einstein might try to prove the existence of the moon without observers, he would never succeed, and he never won that argument. And the whole debate about realism or anti-realism in the quantum world is like that. We find that the simple act of observing the quantum world creates it in a sense. So in the double slit experiment, the way we try to observe the electron determines its basic reality, it seems, whether it appears as a particle or a wave. The observer has a decisive role in constituting reality. Now, this has become enshrined in the famous Schrodinger's cat, which I'm sure you've all heard of. And for those of you who may be a bit hazy on the details, I'll quickly take you through it whilst you're reading those cartoons. So you have a closed box with a cat in it. It is a thought experiment, I should add, and some kind of lethal device, which is triggered at random, say maybe by a radioactive decay or something like that, but it is random anyway. At any moment in time, you have no way of knowing whether the cat is alive or dead until you open the box or you shake it, as in the left-hand cartoon here. At that point, you're making an observation and you know that the cat is either alive or dead for sure. But what about that point before you open the box or give it a shake? What's the status of the cat then? Well, of course, classical physics and human common sense would say that of course, the cat must be either alive or dead, one or the other. But according to the Copenhagen interpretation, the cat is both alive and dead simultaneously. Now, of course, that sounds completely nonsensical. And I should add that this is a thought experiment, not a real life situation. So no one's done this with a real life cat. It probably wouldn't work for various reasons, not only health and safety and animal rights and so on, but it has been tested at the microscopic level in the laboratory. And it's true, the Schrodinger's cat thought experiment does appear to be basically correct, that a quantum system does exist in several states simultaneously. Or you might, philosophers might call that several conflicting ontologies, several different accounts of reality. It exists in those simultaneously. Now, some people, philosophers particularly, have taken the anti-realism implicit in this here, you know, the observer constructs reality, much further, and have concluded that quantum mechanics tells us that all of reality is mind dependent, that our consciousness determines physical reality. But very, very few working physicists would go along with that. We tend to want to maintain a strong commitment to realism, even if it is just an aspiration, really. And yet, if you force us to sort of say, what do we really believe goes on in the box with the cat, for instance, we probably have to fall back to Copenhagen and start saying all these things like, oh, it's alive and dead at the same time, and feel very uncomfortable about it. Thankfully, physicists don't need to debate these things very often. It's for the philosophers and theologians. But even Niels Bohr, who was one of the architects of the Copenhagen interpretation, he admitted that this is very, very difficult, and he didn't feel comfortable. Those who are not shocked when they first come across quantum theory cannot possibly have understood it. And that's, you know, in spite of the point that no one understands it in the first place. But if you're not shocked right now by what I'm saying, then I possibly haven't explained it very well, or it might be work to try and think through what I'm saying. Clearly, it is truly shocking, and I've been doing this stuff for decades. Of course, Einstein was really troubled by all of this, and he never believed that the Copenhagen interpretation was correct. He firmly believed that some kind of deterministic solution would be found one day, where there was a real world out there and we could determine it. And this is a very famous statement that he said in a letter to a friend of his. Quantum mechanics is very worthy of regard, but an inner voice tells me that it's not the true Jacob, not the real heart of the matter, if you like. The theory yields much, but it hardly brings us close to the secrets of the old one. In any case, I'm convinced that he doesn't play dice. You believe in the God who plays dice, and I in complete law and order in a world that objectively exists. Well, I suppose most of us today, 100 years or so further on, in physics, also believe in a world that objectively exists. But over the decades, we've slowly become accustomed to this idea of God plays dice. It seems to work. The science works, even if we don't understand what we're doing. In any case, the alternatives aren't much easier because, as Einstein hoped, deterministic interpretations did present themselves in time, where you do have a fully deterministic real world out there. an objective real world where cause and effect are meaningful. But these interpretations are bizarre. They do not give you reality for free. There's always something outlandish that you have to accept. And the best known is the many worlds interpretation. So this is fully deterministic, unlike the Copenhagen interpretation. And in many worlds, all possibilities are real and they exist in parallel with each other, almost as though we might talk about many parallel universes. So every time Schrodinger's cat turns out to be alive, there's another world created, if in effect, where it's dead. So both branches of, it's called the universal wave function, are equally real and both can contain human observers, but each set of inhabitants in one branch or the other only perceives their own branch of reality. Now, this is fully realist and it's fully deterministic, unlike Copenhagen. And there are lots of other interpretations. I won't go through them, but they're deterministic like this, but they all have their own forms of bizarreness, like many worlds, even if many worlds is the best known one. So the point is that reality, if you want reality in quantum mechanics, it comes at a very, very high price. And it's important also to remember that the actual experiments, the empirical quantum science, it raises all these amazing questions about what on earth is going on here, but the experiments can't answer them. So all of these various interpretations I've listed, including Copenhagen, they're all metaphysical. They tell us about reality on a deeper level that we can actually probe experimentally. So all of these interpretations are consistent with the experimental observations, but we can't decide between them by experiment. So what do ordinary physicists think about this? Well, as I hope you picked up from what I've been suggesting so far, most of us get on with the science without worrying too much about the metaphysics here, because we found that the science is astonishingly powerful. So remember, 11 decimal places. Also, the metaphysics is clearly just too frightening to contemplate, particularly if you think about many worlds interpretation. So one last aspect of the science before I get to the theology, and this is a very important aspect of quantum mechanics, often called non-locality. And theologians have been drawn to this in droves. Now, the idea here comes from one of the objections that Einstein raised against quantum mechanics and the Copenhagen interpretation. And it's come to be known as the EPR paradox after the three people who came up with this idea, Einstein, Podolsky, and Rosen. Now, as I said, Einstein was never happy with the Copenhagen interpretation. He always thought that further work would show it to be mistaken, that actually nature is deterministic, it is objective, we can measure its properties fully, and it's meaningful to speak about a distinction between the observer and the observed. Now, he came up with a thought experiment to try to demonstrate that quantum mechanics couldn't be right, or not fully right anyway. And it's based on an idea called entanglement. This is the idea that two particles that interact in the quantum world are then bound together or entangled, such that if we make a measurement on one, we equally know what the other is doing, however far away the two particles are from each other. So in the EPR paradox, you take two entangled particles and you separate them by a great distance. It doesn't matter. It can be anything, like one opposite ends of the universe. It doesn't matter. You now make a measurement on one of them, and according to quantum mechanics, you find that your measurement determines what the other particle is doing, even though it's so far away that no information can possibly have traveled between them in the time available, even traveling at the speed of light. Now, Einstein referred to this famously as spooky action at a distance. He felt that it was such an absurd scenario, it couldn't possibly be true. There must be some incompleteness to quantum theory. But in some of the most ingenious experiments in the whole of physics, it's been tested thoroughly over the last 30 years or so, and it works. I'm afraid that Einstein was wrong. Entanglement is a thing, and quantum mechanics gets it right. So the Copenhagen viewpoint here is that we don't have two particles at all. We have one entangled quantum entity spread out over a huge distance, which collapses into two particles as soon as we measure it. And that's what we mean when we refer to non-locality. We simply can't assume anymore that by making a measurement at one point in space, we're not affecting something else a long, long way away. And this means that in the quantum world, relationships are more important than individuals in effect. So this is a consequence of non-locality. And as I'm sure you can probably imagine, that's been very influential among theologians, the idea that relationships are more important than individuals. So straight away, it might take you to things like the doctrine of the Trinity. And so it does. So now I'll go on to just go very briefly through sort of I'll just give you an outline of the main parameters of what I tend to call quantum theology, theology done in the quantum world, if you like. So there are four main ways that I've found that quantum theory has been used in theology: the incarnation of Christ, eco-theology and holism, the quantum trinity, and divine action. And I'll take them in turn. So the first uses quantum mechanics to construct a metaphor of the incarnation. And this is the mystery of how Christ could be both divine and human and yet one person. So the idea is that this is like an electron in the double slit experiment. We see it as either a wave or a particle, but nevertheless, it's one thing, it's an electron. So this is analogous to the incarnation of Christ, it's said. So if we contemplate Jesus as a divine being, the Son of God, we see his divinity, but if we focus on his humanity, Jesus of Nazareth, we see his human nature, but nevertheless, he's one being. Well, this analogy has been made many times in theological writings ever since around about the 1950s, but it does have some problems, which I'll mention to you. So if you look at the Chalcedonian definition from 451 CE, of course, that made the point that Christ is both human and is divine, without confusion, without change, without division, and so on. So it states very clearly that Christ is at all times both human and divine, and yet one being. But wave-particle duality isn't like this. We only see an electron as either a wave or a particle when we make a measurement, but we don't believe that it's either one or the other, or both, when we're not making a measurement. So the analogy breaks down once you start to push it hard, and that's often the case with applying science to theological problems. It only gets you so far. Similar issue with the eco-theology and holism field. Here you talk about quantum mechanical non-locality as a metaphor for the fact that humans are not only situated in the natural world, but we're an intimate part of it, connected to it. So clearly that has ecological dimensions, and the word interconnectedness is often used in this area for holistic thinking. A very famous quantum physicist, David Bohm, promoted this kind of thinking in a well-known book called Wholeness and the Implicate Order, the Implied Order. And he has an amazing idea in there. He says that quantum mechanics points to an implied order that we can't see, except through physics. There's a level of reality in the universe that we simply can't see with our everyday senses. But really, we, human bodies, human beings, human minds, are part of a much wider reality. We're just a sort of local manifestations of this thing, kind of flickering into existence, if you like, but we're projections of some single totality. Now, David Bohm isn't being explicitly theological in that book. He really develops that from the physics and his philosophical views. It does, though, as you probably have realized, have some parallels with some Eastern religions, like certain branches of Hinduism and Buddhism, for instance. And you'll find these ideas in New Age spiritualities too, which take their inspiration from quantum mechanics. But there is one quite well-known Christian outworking of this idea in the book by Virginia Stem Owens called And the Trees Clap Their Hands. She develops a kind of pan-sacramentalism about the interconnectedness of the universe. And she has this really memorable phrase, all the world is one great sacramental loaf. She's clearly playing off the Eucharist here, but she does use quantum mechanics throughout to try to point to the kind of interconnectedness of all things. My third example of quantum theology is to talk about Trinitarian thought. So theologians have been quite keen here to use wave-particle duality, again, as a kind of loose analogy for the Father, Son, and Holy Spirit. So three persons in one, and the problems that tend to arise are similar to accounting for the humanity and the divinity of Christ. So similar kind of moves are being made here. The most fully worked out version that I know of is by Ernest Simmons in his book, The Entangled Trinity. And he makes use of perichoresis this ancient idea of mutual indwelling. He talks about the three persons entangled with each other, and then starts a whole sequence of thought about creation theology as well, and explains how the Trinity is entangled with the created world as well. So he really takes this metaphor a long way. I think strengths and weaknesses here as well. So clearly it allows Simmons to make another form of Trinitarian metaphor. I mean, we're all familiar with the various ways in which the Trinity can be explained, particularly on Trinity Sunday. Quantum mechanics gives you another one. But like all of the scientific analogies, it does tend to fall down once you press it too hard. So something that you might want to talk about in the discussion later on. I'm just going to quickly flip through the divine action. This is my fourth example of quantum theology, and this is quite an important one when we get to the quantum transubstantiation section in a moment. This is where quantum mechanics forms a mechanism for God to work in the physical world. I have to warn you, this is a massive area. It's been debated since the 1950s, and it has by far the biggest scholarly literature of all of what I've been talking about so far. It tends to rely on the Copenhagen interpretation, effectively saying that because nature is fuzzy and indeterminate at the quantum level, there's plenty of wiggle room for God to manipulate natural causes, to sort of nudge atoms around, if you like, and bring about purposes in the world. And this is kind of, it's a kind of God plays dice view, in the sense that because quantum mechanics is indeterministic from our perspective, we can't see God's hand at work. But nevertheless, God's hand is there according to this view. And the best known name is R.J. Russell, who has this acronym NIODA, non-interventive objective divine action. He spent a long time arguing the case for this. In spite of, it's had a lot of positive and negative criticism, this model, but it's been the most thoroughly explored idea in the whole of quantum theology. So it's a lot published out there if you want to go and catch up on it. I think that from my own point of view, there are some strengths here, that it sees God tirelessly at work, always and everywhere. But there are also problems, which is that God is tirelessly at work, always and everywhere, in the evil as well as the good. So this position, it kind of potentially falls down when you start to press it too hard. But this brings me on to the whole idea of quantum transubstantiation. So there's quite a lot of text on the screen, and I will read it through carefully with you in a moment. But I just want to say that this is really, I'm kind of pushing a boat out here. I'm not aware that anyone has ever discussed this in theology before, in science and theology. And that might be because the vast majority of my colleagues tend to be pretty firm Protestants. But for those of us who are more Catholically minded, the idea that God works unceasingly at the quantum level instantly, at least in my mind anyway, relates to my view of the Eucharistic transformation. I had a look at the SCP website, but I couldn't find anything there about transubstantiation or real presence. I might have been looking in the wrong place, so please tell me if there's stuff there. But nevertheless, for me, and I suspect that many Anglican Catholics, I would usually start with the Catechism of the Catholic Church if I want to find out about something. And I found the appropriate two paragraphs, 1374 and 76, and they go like this. The mode of Christ's presence under the Eucharistic species is unique. It raises the Eucharist above all the sacraments as the perfection of the spiritual life and the end to which all the sacraments tend. In the most blessed sacrament of the Eucharist, the body and blood, together with the soul and divinity of our Lord Jesus Christ, and therefore the whole Christ, is truly, really, and substantially contained. And these are, this is a quotation from the Council of Trent, by the way. This presence is called real, by which is not intended to exclude the other types of presence as if they could not be real too, but because it's presence in the fullest sense, that is to say, it's a substantial presence by which Christ, God and man, makes himself wholly and entirely present. Now, there's clearly a lot packed into that, some technicalities which we may want to debate later on, but please note that, of course, it talks about presence, real presence as well, reality, substantial presence, God makes himself wholly and entirely present. I mean, this is not a kind of playing around with word stuff, is it? It's trying to say quite clearly that this form of presence actually really happens in the world. Next paragraph. The Council of Trent summarizes the Catholic faith by declaring, because Christ our Redeemer said that it was truly his body that he was offering under the species of bread, it's always been the conviction of the Church of God, and this Holy Council now declares again, that by the consecration of the bread and wine, there takes place a change of the whole substance of the bread into the substance of the body of Christ our Lord, and of the whole substance of the wine into the substance of his blood. This change, the Holy Catholic Church has fittingly and properly called transubstantiation. So there you have it, transubstantiation, fairly clear definition there. And notice, of course, at the beginning of that paragraph, according to the Council of Trent, this statement is not optional. It's a summary of the Catholic faith. Again, I would love to hear what other Anglican Catholics think about that. I can tell you my own opinion too, but there you have it. So Christ is present in the Eucharist as an objectively real, true, and substantial way. It's not a symbolic or metaphorical presence, and neither, very, very importantly here, neither does the presence exist at the supernatural level. I'll leave that for a moment to sink in. The presence does not exist at the supernatural level. Now, much of the thinking behind these statements were inspired by Thomas Aquinas and other medieval theologians who worked with Aristotelian metaphysics rather than the kind of stuff that we tend to think of these days in terms of atoms, atomistic metaphysics. So in the Aristotelian or the Thomistic solution, the substance of the bread and wine change in the consecration. They change to the literal body and blood of Christ, but the accidents, that is the appearance, if you like, remain unchanged. So the bread and the wine change to the true and literal body and blood of Christ, but they still look like wafers and wine. Well, the scientific revolution pretty much rejected Aristotelian metaphysics. So we have a bit of a problem in the modern world trying to understand this stuff if you're not an Aristotelian. Is there a modern or quantum way of saying all of this in terms of scientific substances like atoms and particles? Well, not clearly, although the kind of question I'm raising here is similar to how you might interpret, for instance, the miracle of the wedding at Cana. How did all of that water turn into wine? You need to start thinking in terms of chemistry if you use the modern metaphysics informed by the scientific revolution. Similar kind of thing, really. You could use quantum mechanics here to start thinking about the way that particles and atoms might be transformed from one to another. So if the water can be transformed to the wine in terms of quantum mechanics, is it possible to think of the wafer and the wine in the Eucharist being transformed to the body and the blood? Is this the kind of thing we're talking about? I'd be interested to know your thoughts here. Well, there is some thinking in philosophy of science at the moment developing neo-Aristotelian ways of approaching quantum mechanics, which tends to reject the talk of kind of atomism and everything is fundamental particles at the end of the day, and tries to go back to see what can we do about interpreting quantum mechanics in Aristotelian terms. Now, this is very, very new work. The stuff I've seen hasn't even been published yet, so I hesitate to say too much about it. And I'm not a Thomist myself, so I don't know that I would fully understand the issues. But clearly, if you wanted to make something of transubstantiation in scientific terms, this is clearly the way to do it. Well, I'm aware that this is by far the sketchiest part of a very sketchy talk. And I don't have very clear ideas myself. And as I keep saying, I would love to hear your ideas here. And I think two of the questions I would like to leave you with as I finish up is, does it matter to worry about these things? Am I being overly literalistic? And for that matter, is the Catholic doctrine of real presence that we have here a bit too literalistic to begin with? So in addition to what Jamie says, I'd like to introduce those two questions. Does it matter? And am I being too literalistic? And is the catechism being too literalistic? Well, let me finish just with my summary, just so I can remind you of what I've said. So I started out by introducing this problem that nobody really understands quantum mechanics. I introduced the measurement problem, where it turns out that we can't measure quantum entities without effectively becoming a part of the experiment ourselves and biasing the experiment. I talked about what might it mean and introduced things like the many worlds interpretation and the really difficult problems between realism and anti-realism. Is it the case that our minds are constructing all of this? And then I very, very quickly gave you a few ideas from quantum theology before finishing up with these precarious, I think is the best word, ideas from quantum transubstantiation. So I will stop there, very gladly stop there, because I think I'm running out of my own ability to explain this stuff, and hand over to Jamie.
Mark, thank you so much for what has been, as always, a clear and stimulating presentation of the intersection of two significant topics in science and religion, quantum mechanics and transubstantiation for us this evening. They are both challenging in and of themselves, and you've brought them together in such rich and provocative ways. Not only was I shocked the first time I came across quantum mechanics, but I am shocked anew each and every time I encounter it. And I indeed wonder if I will ever truly understand it, but that has nothing to do with your excellent presentation skills tonight. And it has everything to do with the perplexing nature of this scientific theory itself. And it's always good to know that I'm in good company, according to Richard Feynman. You've also provided in your talk tonight a valuable insight into the nature of theorizing at the intersection of science and religion. That one must deeply explore the nature of the science component with all areas for us tonight, quantum mechanics, and the nature of the religion component with its various theories for us, the Christian Eucharist. It's an important reminder that science and religion are never monolithic entities with a single intersecting point or method. Rather, one must explore specific permutations of various theories from each discourse. As a priest, I can see an abundance of possibilities in the various aspects of quantum mechanics that I can sink my theological teeth into. We have the seeming collapse of the clear distinction between observer and observed, and its potential implications for the relationship between nature or creation and divinity or the creator. We have the potential indeterminate state of nature at the level of cause and effect, and the implications this might have for when or where the Eucharist occurs in the continuum of space and time. Then we have the relationship between metaphysics and science, and the implications for the role of belief or faith in choosing between vying theories. And finally, we have entanglement and relationality. As you pointed out, these have implications for how we think about creation, incarnation, and the triune nature of our God. What I find so thrilling in listing all of these possibilities is the affirmation that priests engaging with science, and in this case, the theories of quantum, are in fact doing theology here tonight. Whether we are doing good theology might be a different question, but nonetheless, we are doing important theological work here, bringing theological doctrines into the light of current knowledge about our world. Ever since engaging with science and religion field, I've considered this sort of an investigation training in how to ask good questions and develop rigorous theories rather than simply coming up with correct or certain answers. Getting us here tonight as religious leaders to engage with current science is of inherent theological value. even if this science ends up being drastically different in 100 years' time, as science so often does. So I'm actually encouraged by your questions at the end, your tentativeness about the sketchiest possibilities of this sketchy exploration, because it models for us what it is like to engage in the big questions that motivate religion and science, and what it can look like to be drawn into the awe and wonder of exploring the natural world, and drawn ever deeper into the mysteries of the divine. So what about quantum theology, as you're calling it, or quantum transubstantiation? It strikes me that all four of the different contact areas you identified, incarnation, ecotheology, Trinitarianism, and divine action, that they're all interrelated and can all feed into any quantum substantiation theory that might come out of your thinking. Ecotheology and incarnation are already connected via deep incarnation, which encourages us to think about the incarnation not simply as being human, but incarnation as going into the very matter of all creation. So this touches directly on the Eucharist, just as in that quote that you mentioned from Virginia Stem Owens, that all the world is one great sacramental loaf. And it seems to me that Trinitarianism and divine action and our topic of transubstantiation all come into play, specifically in our Eucharistic prayers. And I'm particularly thinking about the epiclesis, for example, in our 1982 Scottish Episcopal liturgy. Hear us, most merciful Father, and send your Holy Spirit upon us and upon this bread and this wine, that overshadowed by his life-giving power, they may be the body and blood of your Son. Here we are, in a way, invoking all three persons of the Trinity and asking or praying for a specific divine action. So these four areas seem to me to bring together the dynamic, interrelated, and yet indeterminate nature of reality revealed by quantum mechanics and revealed in the great mystery of the Eucharist. One final thought from me comes from my own area of research in science and religion, which is the role of story or narrative or mythos at the intersection of the two. And this is actually kicked off by your own at the end. Are you being realistic with the possible implications of quantum mechanics for the Eucharist? Or challenge thrown back to us as theologians, is the doctrine of real presence itself overly realistic? I'm going to read a series about science scientists that you'll already be familiar with, Mark, but I'll read them out for the rest of us. These were drawn together by a literary scholar named Stephen Prickett, who was writing on the narrative nature of religion and of science. Prickett provides a series of statements in order to introduce the concept of science itself as narrative. So here are four of them. We have Niels Bohr, who says physics tells us not what is, but what we can say to each other concerning the world. Or Jean-Francois Lyotard, who says there is no scientific method. Scientist is before anything else a person who tells stories. Or John Gribben, a physics writer who commented at the end of a lengthy discussion of quantum theory. He says, I do not claim that it is anything more than just a fiction. All scientific models are simply Kipling-esque, just so stories that give us a feeling that we understand what is going on. And then we have Stephen Jay Gould, who claims science is best thought of as a series of interpretative or adaptive stories to explain certain phenomena. So I kick off this discussion time with the following questions. What might be the role of story or narrative in our understanding of quantum mechanics? And in fact, in our understanding of transubstantiation? And how might this address any concerns about being overly literalistic? And how might that impact the meaning one derives from the Eucharist? So thank you again, Mark. Thank you for taking the risk to explore this intersection with us tonight. And I look forward to hearing more of your thoughts, as well as the thoughts of everyone else gathered here this evening for this exciting, if highly sketchy, discussion.
I will open up the room to questions, but before I do, I wonder, Professor Harris, is there a response you'd like to make specifically to some of the things that Jamie has said?
Thanks, Oliver. Yes, just a few thoughts. So I was aware that when I got to the Eucharist right at the end of my talk, I did it very, very quickly, partly because I think I was scared of what I was talking about. But I was glad that Jamie was able to fill it out a bit and introduce some of the areas that we know and love about this particular theological issue. I think it was very important that she mentioned the epiclesis, for instance, and the three of us, at least, are in the Scottish Episcopal Church, where we do have this lovely tradition of the epiclesis in our Eucharistic prayer for hundreds of years. So this is something I was very glad that she mentioned the three persons of the Trinity and the priest asking for divine action there in front of them on the altar, which is a wonderful, wonderful moment. So is this what we're talking about? I was very glad that you brought us back to that and the words that we say. Also, I was really interested at the quotations you used at the end, emphasizing the story and narrative thing. I would have to think a bit further about that because, like I said, probably several times through the talk, as a physicist, I tend to think of quantum mechanics in this very precise way, as it's a source of numbers that work for me. How do you introduce stories into that? Well, I'm sure there are some, but I think that's probably for others. So I'll stop talking.
Thank you very much. Now, you'll recall that Professor Harris has left us with two questions to consider as a group. I mean, if you think it's just two questions, then I don't know if you've been to the same talk that I have. But he did try to boil down for us two things he'd like for us to consider as a group, and that is, does it matter to worry, and is the doctrine too literalistic? I'd like to open up the room now. I will take off my spotlight and I'll be able to see, hopefully, some of your hands as they're raised to ask Professor Harris any questions about this, or indeed to make any observations on what he said. If I start with something that's been put into the chat, I don't know, Professor Harris, if you can see this. It's Father Ben Edwards. He asks, so is a working hypothesis that transubstantiation involves both the reaction of Christ to the observation and/or intention of the priest and the worshippers present at the Eucharist, and almost a reverse of the entanglement of particles. That is, when observed, the divine, by choice, becomes entangled with human reality. Christ becomes entangled with the host in a way that enfolds those partaking of the sacrament into the divine reality of the Trinity.
Thank you very much. That's you've made a very nice little addition there, contribution, I think, of thinking via the chat in quantum terms and developing the analogies and metaphors in that I think when we discuss the real presence and the idea of the sacrifice of the Mass, I think that people often get left out of this conversation, don't they? And certainly those in more Protestant wings of Christianity often want to major on the people here, and also on the memorial idea as well. Of course, that's an important element of story. All of this takes place in the context of the priest reciting the words of Christ himself. That may not be the moment of consecration, and we may have different beliefs about where that happens, if there is a where, a precise where. But nevertheless, I think you've done a really nice job there of introducing some of the quantum metaphors into our understanding. And it might well be that what I've been talking about is best understood in metaphorical terms anyway, but I think the question I was wanting to, well, what worries me is that the Council of Trent statement, which is recorded in the Catechism, tries to make it very clear that the real presence does not work in a symbolic, figurative sense. But when we try and explain it, we have to resort to those terms. So, but thank you anyway for your comment.
Thank you. Are there any questions that folk want to pose or observations? I'm looking for using the raise hand feature. And I see you, Father Ian. I'll just highlight you here. Please.
Thank you, Oliver. Just to answer Mark's questions at the end, personally, I speak as someone who trained as a material scientist, but has also been a priest for 40 years. And I don't think it does matter, is the answer. I think the idea of metaphor that both of you have introduced is splendidly helpful to me on an understanding of the Eucharist, but also as a scientist. And I can't unravel this thought, and you're more experienced than me at this, particularly I think, Jamie, on this, that somehow what you said, Mark, was for me a story.
Thanks, Ian. You've just given a very clear answer to my first question. I'm really grateful for that. Thank you. I wonder how many others would say it as clearly as that. I'll be interested to hear that as well. I suppose what I'd like to ask you, by way of a response, is perhaps a less complicated example of something similar, namely what I mentioned towards the end of my talk, the wedding at Cana. How do we think the water became wine? And I suppose, again, does it matter?
I very quickly respond, but I don't want to say anything more after this because there's lots of people here. I think there is something in all this, and we didn't discuss it in the talks, about the dimension and significance of time and how we see it and perceive it. So that it seems to me the miracle of Cana in Galilee was simply the miracle of speed in time. Material change happening that happens normally in the making of wine, but at a speedier rate. I'm very much oversimplifying, but I would introduce the dimension of time to the discussion.
Okay, thank you. Yeah, so you responded in a way that I wasn't expecting. Namely, you introduced a kind of a literal, it happened in the real world kind of explanation. Maybe Jesus introduced some miraculous kind of enzyme into the mix or something like that. The objection that I most often hear from people, and I suspect that others will want to contribute to this, the objection that I most often hear from people is, it doesn't matter, why do you have to literalize it? You know, I can just enjoy the story and it informs my prayers and my faith. And I suppose my response would always be, well, so do you not believe then that God might be able to work in the world and change water into wine? But anyway, I'm sorry, we should let other people come in, shouldn't we? Because there are a few hands up.
Thank you very much, Father Ian. Amanda, let me highlight you here and ask you to unmute. Mm-hmm. Mother Amanda.
Oh, don't call me mother. Please, sorry. Thank you so much. That was a really interesting lecture. Does it matter? Are we taking it too literally? Are we being too literally? I think it depends on the individual who is trying to seek after the truth of the matter, and we're in danger of reducing a great big holistic God into individual little particles if we're not careful. But I really liked what Jamie had, the question that Jamie gave to us about the narrative being important. And it occurred to me that perhaps science, and particularly physics, which was my first degree, but I'm not very good at it. I only got a Douglas. Science and physics, and also maths, ways in which God tells God's stories to God's people. And by continuing to try to understand science, by continuing that investigative process, we're getting closer or getting deeper into the story.
Thank you very much, Amanda. A very helpful couple of contributions there. Yeah, I think you're right, actually. Reductionism is a bit of a dirty word in philosophy of science. So we scientists, particularly physicists, do it all the time and think in reductionistic terms, because it's been so powerful in the history of science to break problems down to their basic elements. And it's one of the main ways in which physics, at least, and chemistry as well to some degree, biologists as well, have made progress. It works astonishingly well, but I think we sometimes get misled by that success into thinking that that's the same as the whole. But we're coming across many problems in sciences now which simply don't seem to work by reductionistic thinking, particularly when you get to trying to explain the reality of the human being, like the way our minds and consciousness work, for instance. So yeah, that's I think it's a very useful point to make. You know, don't be too reductionistic, and that if we try to reduce the mystery of the Eucharist to the mystery of quantum mechanics, we might perhaps be doing reducing a bit too far there. I think you've also, again, affirmed Jamie's viewpoint, namely that, again, you know, science isn't everything, I suppose. It's easy to forget that when you're a scientist, particularly in a society which tends to hold the sciences up as the foremost banners of truth in a way. But story and narrative are useful ways of integrating science and theological perspectives. Yeah, thank you very much.
Excellent. Thank you, Amanda, for that. I call on Andy. I'll just add a spotlight to you and ask you to unmute yourself.
Just checking there's only one Andy in the room. Briefly, because there's a lot of discussion going on. One is, I think there's an interesting connection between story and metaphor and allegory to be explored. I'm an engineer, you know, so we bring the fruit, you bring the light to the scientist, and we bring the fruit to the table. So I think there's something there about the way that metaphor is story, to expand that as a way we use metaphor and allegory in scientific and engineering training and so on, as to how physical processes work. I think also want to reinforce what Father Ian was saying about time. I think there's some really interesting thinking to be done about what is God's time and our time, and what we understand about the dare I call it, elastic, plastic, or the plastic nature of time, shall we say, within whatever we think is reality. And finally, you've thrown it out a couple of times as a throwaway line that many people at the interface of science and theology are firm Protestants. And I just wondered whether it's twice now, it's clearly something that's in your mind, and has been in mine. I'm a postgraduate researcher now, I've retired from engineering, and finding a number of very firm Protestants in that field. And I'm just wondering any observations on that, or whether it's really just statistically significant or not.
Thanks, Andy. Yes, that's a really difficult question to answer. I can, yeah, thank you. You've kind of picked me up there. I can say, I wouldn't normally say it in a talk, but I felt that Society of Catholic Priests, I was probably on safe grounds. I often feel a bit yeah, a bit too Catholic in most of the professional circles I work in, because I simply don't think in the same ways as most of my colleagues who are also Christian theologians. Of course, the field of science and religion has broadened tremendously over the last few years to include people of all faiths and none as professionals in it. But certainly for the first few decades, it was dominated by the Christian theologians. And most of the big name thinkers that tend to write the big books that we still refer to they adhered to relatively kind of Protestant forms of Christianity. I suppose two well-known British names that you'll probably have heard of are Arthur Peacock and John Polkinghorne. Now, they were both Anglicans, of course, and Arthur Peacock certainly, I'm sure he would object to me calling him a Protestant. Nevertheless, Polkinghorne was certainly, he was very open about being an evangelical. By and large, yeah, I think I should, since you've picked me up on this, I need to think more about it and maybe do a bit of a head count.
And maybe look east. Maybe look east.
Yeah. Unfortunately, Orthodox Christians haven't done very much in this field yet, but there is some wonderful stuff coming out. But it's very few and far between, the Orthodox scholarship in science and theology, and there's not a great deal of Roman Catholic thought in it either. I mean, there's a few names, but they tend to be drowned out by all of the many Protestants and Anglicans. And of course, we all know that Anglicans and Episcopalians can appear Protestant sometimes and Catholic at other times, and who knows what we are.
Can I ask a question, Oliver? Sorry.
Yes, of course, Kenson. Let me highlight you for the.
Thank you very much, Professor Harris. I work from a more sort of philosophical background than physics. And I wonder, and thank you for bringing up the liturgy in the Eucharist. And I suppose my question would be, a lot of my work was on speech act theory and how you do something with words, and that's very salient in the Eucharist. The moment the recalling the words of the institution. And so would you see that actually there would be a sort of physical explanation or theory to link physics, transubstantiation and speech act theory, sort of bridging linguistics and physics?
Thanks, that's a really interesting suggestion. Now, I'm a little bit fuzzy on speech act theory, and I wonder if other people know more about it than me. Could you just explain it?
It sort of just basically say, when you say something, you actually make things happen. So the most famous example, which the linguist himself used, was when you solemnize the holy matrimony, you pronounce them husband and wife, and by saying so, you have changed ontologically the relationship between two people. And so my question, so where I'm leading is, look, of course, Schmemann would have said the world as sacrament, and that links into what you've said wonderfully. But I wonder if actually speech and action in the Eucharist facilitates, or in some way, it's perhaps like an experiment, how we observe or how we interfere with matter through experiments, as you were talking about at the very beginning, that actually liturgy itself is a key element to how all you've said happens physically.
Thanks, a really interesting question. So yeah, I can see that when the priest says the Eucharistic prayer, then in the hearts and minds of the people, the Eucharistic elements are transformed. But does that mean that they are transformed in substantial terms as well, in themselves? Say if there wasn't a congregation there, would they still be transformed? Here's a good question for you. So not for you, for anyone who's listening. When the elements are in the aumbrey, in the empty church, and there's no one there, are they still the body and blood of Christ? just like the tree falling in the forest, isn't it? I suspect that most of us would think, yes, they are still the body and blood of Christ, even in an empty church. But why would we say that? And what do we mean? What do we believe? And I think the Council of Trent and the Catechism is pretty clear on this. And I'm very, very interested that quite a number of people so far have talked about story, metaphor, narrative in ways I'm almost wondering if you're trying to move away from what Trent is saying so very, very clearly here, that maybe we're feeling really uncomfortable with it. Of course, I imagine that most of us Anglicans, so we don't have to adhere to this anyway. But I'd be really interested in what people think about Trent and the Catechism. But thank you very much. Really, I think what you said there clarified one of the undercurrents of discussion.
Thank you, Kenson. Mark, I have a question. Can I ask? Quantum mechanics introduces this concept of the observer principle. I remember the first time I heard about it, it absolutely blowing my mind, the fact that observing something could actually change the outcome of an experiment. In the context of transubstantiation and the Eucharist, this change that happens where the elements are believed to undergo a profound transformation, might you just unpack a little bit, in theory, perhaps, even if you're comfortable, how might the observer principle align or intersect with the theological understanding of this miracle? Does it offer any insights or challenges in reconciling the physical and spiritual aspects, do you think, of the Eucharist?
Gosh, yeah, that is a really hard question, Oliver. Thank you, I think. One way of possibly interpreting what you've asked is to say that for the person of faith who believes in the real presence, then for sure, the Eucharistic elements are the body and blood of Christ. But for the person who has no faith whatsoever, they're just bread and wine in real terms. Now, that would be a very subjective understanding, I suppose. Although in today's pluralistic world, it is a way of, I don't know. I keep saying I'd love to hear what people think about this. Most of this talk, you'll probably realize, is a bit of a thought experiment. I'm making it up as I go along. So thanks, Oliver, for presenting me with this dilemma. I would like to be able to say that the Eucharistic transformation is more objective and more real than that. So it's not just the same as the quantum measurement problem, even though quantum mechanics may well be involved, we might believe. And I'd like to go back again to, stake my faith, if you like Martin Luther, on the Council of Trent and the Catechism as my kind of, this is what I'm trying to maintain. It's so very difficult, but I'm trying to.
Great, thank you very much. Are there any other questions for Professor Harris? Excellent. Yes, Martin, let me highlight you here.
Thank you very much for an amazing talk and opening this out to me, to all of us. I just wondered whether we could reflect briefly on the epiclesis that takes place, arguably, at the ordination of the priest. The sacrament of ordination, what is actually going on there? And it seems particularly relevant to us because there's so many of us here, I'm sure, are ordained priests, and therefore as the subjects of the ontological change that we went through at our ordinations, we are then able to subjectively reflect on what God may have done at that moment.
Thanks, Martin. Yeah, so I haven't I don't have it to hand. The Catechism is always reliable. It has got a long section on ordination as a sacrament. I know that it does say that the Eucharist is the kind of preeminent sacrament and that all others are effectively derivative from it. I can't remember what it says about the ontological change in ordination, I'm afraid, nor how it might the kind of terms it would use. I expect that I'm not sure that I would want to use quantum mechanics to do it, except in just very kind of loose metaphorical ways. But whereas when we're talking about the body and blood of Christ, the bread and wine transforming, that seems to be much more about the materiality of what we're about here. The ontological reality of the priest is probably not, that doesn't seem to clearly get at physics to me, but I could be wrong.
I was just taken by what Kenton was saying, Lee Kenton, about the speech act when the bishop speaks over the person being ordained, whether something is happening there that then the priest as subject then actually experiences over the course of their ordained ministry. And even when they're laid their feet, they're no longer able to function anymore. The concept of the priest of going on until you've died, in that sense.
Yeah, no, thank you, Martin. Yeah.
Thank you very much, Martin. Other questions or comments?
Sorry, can I just really quickly jump in? I know time is running out. I suppose thinking about the analogy of a liturgy and experiment, I was thinking, as Martin was saying, the ordination. It to me seems like, just like when you do the young slit experiment, you have a set of criteria and you have a set of conditions and you observe it and things happen sort of according to our expectation or not. Sometimes we get surprises. So does ordination on the Eucharist. We are constructing a very specific condition with a set of criteria that needs to be met, and things just happen. So perhaps there is a link there with science and quantum mechanics in ordination.
Thank you very much. Yeah, I think ordination is not something I've thought through in these terms at all. So I'm grateful to hear anything anyone has to say, actually. And in that light, I've noticed that Jen Holder has just put a comment in the chat, which intrigued me, actually. I'll just read it out because I do have an answer for this. Living in Scotland, this happens to me quite frequently. And she says, I think so, as a priest myself, what if I go to church down the road, which is much more Protestant, can I still receive the elements and believe in the real presence? Well, so I work in an institution, it's the School of Divinity in the University of Edinburgh, but it's also a Church of Scotland training college, seminary. And so I often go to the communion services there, which are very often led by Church of Scotland ministers. And our principal noticed that when I go and it's led by an Episcopalian, I cross myself and do all the stuff. But when she takes the service, or any Church of Scotland minister, I don't cross myself or do any of the stuff, any of the kind of manual actions or anything like that. And she said, why don't you do that? Do you not believe that this is the communion? And I said, no, when you are celebrating, I believe what you believe. So I wouldn't try to impose my own beliefs on you by doing all of these kind of alien rituals. I know that she believes that the Eucharist is a memorial action. It's not a sacrifice. So therefore, I believe that when she's doing it, it's a memorial action, not a sacrifice. So does that help, Jen? I'm not sure, but so I suppose maybe I'm being a little bit able to move around in what's the word I'm trying to think of? I can't think of it, a bit chameleon-like, but that's how it works for me, because I do go to a lot of different ecumenical communion services.
Yeah, thank you. That is very helpful.
Thank you very much, Jen and Mark. We might have time for one more question if someone would like to indicate their desire to speak. All right, well, I will draw this to a close then. And as we come to the end of this enlightening talk, I'd like to express my heartfelt thanks to Professor Harris for sharing his profound insights and perspectives on the intersection of quantum mechanics and the Eucharistic mystery. Professor Harris, how can you be so good? As Dr. Wright said, you have given us a lot to dig our theological teeth into. Your expertise and ability to bridge the realms of physics and theology have broadened our horizons and stimulated our intellectual curiosity. I'd also like to add my sincere appreciation for Dr. Jamie Wright, our responder, for her valuable reflections and thought-provoking questions that further enriched our understanding of this truly fascinating subject. All of you who have followed on so brilliantly from it with your own questions and observations, thank you very much to you too. And to all of those who have sat quietly, wondering and pondering, well done. Before we conclude, I would like to remind all of you that our lecture series continues tomorrow at 7:30 p.m. BST with another captivating talk by the Reverend Gerald Robinson Brown. He will be exploring the fascinating topic of the shape of the Eucharist in early African Christianity. I invite you all to join SCP for what promises to be another insightful evening. And finally, if you like this kind of thing, the grappling with ideas and theology, SCP might offer a place for you to belong. If you don't already, but if you'd like more information about the Society and membership and what it's all about and how you might get involved, you can visit us online at www.societyofcatholicpriests.com. Once again, I extend my heartfelt appreciation to Professor Mark Harris, Dr. Jamie Wright, and all of you for your enthusiastic participation. Thank you and have a wonderful evening.